In this video, I'm going to look at area. Now, the area of a shape is the amount of surface that it covers. Area is given in square units such as meter squared or centimeter squared. Next, I'm going to look at area of a triangle, followed by area for a parallelogram, and then area for trapezium. I'll start with the area of a triangle. Now, suppose we're given a triangle that's given here, and we want to find the area of this triangle. So it can be any arbitrary triangle. Suppose you have this one here. Now, I'll use this application to help you discover area of a triangle. I'll start by dividing the rectangle into two equal parts, like that. And then I'll drop a vertical line to divide the upper triangle formed. And then I'm going to move each of these little triangles here over here, and then this one here over the other end. This is what I mean. I'll move that one to fill that gap, and then I'll move that one to fill that gap. Somewhere there. All right. So the resulting shaded area is basically half of the original rectangle. So this area is half of the original rectangle. Now we know that suppose this is the height, and that's the base of the original rectangle. We can see that what we have here is half of the original rectangle. So basically, the area of the triangle, which is shaded here, area of triangle, so area of triangle, which is shaded, is the base multiplied by the height divided by 2. Remember, here we have the base of the rectangle and the height of the rectangle divided by 2. That gives us the area of the shaded part, and the area of the shaded part is the area of the triangle that we had initially. So, going back to our notebook, we can say that area of a triangle is equals to base multiplied by the height divided by 2. So we need to identify the base and the height. Or we can say area is equals to a half multiplied by the base multiplied by the height. They all mean the same thing. Still on triangles, I'll look at something else here. Now, you can have different shapes of triangles, but the most important thing is you have to identify the base and the height. In this case here, you can see that the base is 8, the height is 6, and therefore we have the area of 24. Now, I'm going to keep the height and the base the same, but change the shape, and you can see that the area does not change. Why? Because we have the same parameters. We have the same values for the base and the same values for the height. Okay, so you can have a triangle like that. What matters most is what's the base and what the height is. And that's what gives you the area. The area is still 24. Even if I move it to that end, maybe somewhere there, making a right angle triangle, you still have the base and the height being the same, and therefore you have the same area. Now, one other thing that you need to realize is the base and the height are always perpendicular. The base and the height are always perpendicular. Yeah. And you can use that idea to identify what's the base and what the height is, right? They're always perpendicular. If I move this around, you can always see that. Anyway, I'll move on to the next shape, which is a parallelogram. Now, for parallelogram, this is a parallelogram, and I'm going to use this application as well to help you discover the area of parallelogram. Now, this is the base of the parallelogram, and this is the height of the parallelogram. But what I'm going to do is to transform this parallelogram to make another shape. So I'm going to transform it to make another shape. Remember, the base is still the same. This was the original base. So the base is still the same, and the height is still the same. So what we have here is that is the base, and that is the height. All right? And the new shape that we have here is a rectangle. And we know that area of a rectangle is equals to base times height, which means that area of a parallelogram is given by base multiplied by height. So we go back to our notes and say that the area of a parallelogram is given by base multiplied by height. I have this shape here, which is a trapezium, and I'm going to use this application to help you discover the formula for area for trapezium. Now, the first thing that I'm going to do is to rotate the shape. But before I do that, just remember this is B. One of the parallel sides of trapezium here is B. Another one is A, and we have the height, right? So we have A here, B here, and the height. Now I'm going to rotate this shape, just to double it, rotate it, so that I have another exactly a congruent or exactly similar trapezium on the other end. So I've just doubled this trapezium from the original one and attached it to a similar trapezium over here. All right, that was the original. Rotate it, form another shape by pairing the two trapezium together. And now what I'm going to do is to shift this bit to the other end to end up with that. And you can see that the resulting shape here is actually a rectangle. Now, for this rectangle, it has a length, actually right here, it has a length of A plus B, right? And then it has a height of H, which means that the area of this rectangle will be A plus B multiplied by H. But remember, our goal is to find the area of one trapezium. These are two trapeziums. So what we need to do is we can divide this by 2 to find the area of one trapezium. All right. So area of a trapezium will be A plus B multiplied by height divided by 2. Because what you're having here, if you just multiplied H multiplied by A plus B, you'll end up with the area of two trapezium. But we just want the area of one. That's why I'm dividing by 2. So what we'll do is we'll go back to our notebook and say that the area of a trapezium is equal to A plus B multiplied by height divided by 2. where A plus B are the parallel sides. So where A and B are the parallel sides, and H is the height of the trapezium.